Good morning, everyone. So, in the previous class, we have discussed about network types. So, what are the network types? We have BMA, past 3 days, NBMA, point to point, point to multi-point, broadcast, point to multi-point, non-broadcast. So, if we talk about BMA and NBMA, we have DR-BDR election. So, what about the timers? So, if we talk about NBMA, we have hello is 10 and dead is 40 seconds. If we talk about NBMA, hello is 30 and dead is 120. Then, if we talk about the neighborship, BMA has dynamic neighborship. So, on the NBMA networks, you need to use a neighbor command statically. Then we have point to point. So, if we talk about point to point, we have no DR-BDR. So, the timers is again 10 and 40 and dynamic neighborship. So, we don't need to use a neighbor command in order to form neighborship when the network type is point to point. So, if we talk about point to multi-point broadcast and point to multi-point non-broadcast, so there is no DR-BDR election again. So, if we talk about the timers, hello is 10, sorry, hello is 30 and dead is 120. So, if we talk about the neighborship, point to multi-point broadcast has dynamic neighborship, and point to multi-point non-broadcast unit is a static neighbor command. So, we'll do a lab, short lab, in order to prove all these network types. So, we'll take two routers and then we'll see what is the DR-BDR election, what is the hello and dead timer, and the neighborship type as well. Wash your face. You should take a breath and sleep. Okay. So let us take two routers. So both are in area 0. So the IP address will be 192.168.12.0/24. Both the routers are in area. So the by default network type on the routers is BMA. Just wait for 1 second. 0 So the IP address will be 192.168.12.1/24. Okay. Router. Router ID will be 1.1.1.1. Network 192.168.12.0. Wildcard mask and area 0. So go to R2. Interface 0 So the IP address will be 192.168.12.2/24. Motion. Enable OSPF. So router OSPF 1. So router ID will be 92.168.12.0. Wildcard mask and so then form the adjacency. So if we talk about the adjacency criteria in OSPF, so first adjacency criteria is the common subnets. Both the routers should be on common subnets. Second, periodic and load transmission. Third, area ID must match. Fourth, authentication must match if enabled. Fifth, unique router ID. Sixth, timers must match. Seventh, we have network type must match. Area type must match. Passive interface should not be enabled. MTU must match. So these are the OSPF neighborship, sorry, adjacency criteria. So whenever your OSPF neighborship is stuck, then you can check these points. So you can verify with the 10 points for the troubleshooting. So I hope everybody knows about common subnet, periodic hello transmission. So if you do area ID mismatch, then there is no adjacency. So authentication, we'll be verifying this today. So unique router ID. So if router ID is same, they will not form the adjacency. So timers must match. I'll be showing you in this network type. And even the network type must match. Area type. So area type we'll be discussing. There are 5 types of areas we'll be discussing after this network type. Then we have passive interface should not be enabled and MTU must match. So these are the 10 adjacency criteria you need to verify for troubleshooting. So 3 commands for OSPF troubleshooting. Please mention this. Show IP OSPF interface brief. You can troubleshoot any problem. Show IP OSPF neighbor and show run pipe section OSPF. So these are the 3 commands you can use for troubleshooting. One more command if you want to use. Show IP OSPF interface. Interface. It will show you the timers and the no? Okay. So this is fine. Show IP OSPF. This is fine. Now, if you check show IP OSPF interface. Interface. So the by default network type is broadcast. What is the hello and dead? 10 and the 40. And if you talk about the DR BDR election, so we have a, can you see it? I hope 3 points are clear with the broadcast and dynamic neighborship. So we check sure on pipe section OSPF are not used any neighbor. Clear? So these are the 3 points you need to remember about this network. So now we'll change the network type. Go to the interface name, IP OSPF network. Question mark. Can you see it supports broadcast, non-broadcast, point to multi-point broadcast, point to. And if you want to have point to multi-point non-broadcast, you can use the keyword non-broadcast. Okay. So now we'll try with non-broadcast. As soon as you change the network type, your adjacency will be down. Why? Because on the neighboring router also, your network type must match. Here, go and change the network type on R2 to non-broadcast. Interface name, IP OSPF network, non-broadcast. Show IP OSPF name. Why don't I have a neighborship? What did you show here? We don't have dynamic neighborship here. You need to use static neighbor command. Can you see? I don't have any neighborship. Wait for a few more seconds. Here, you need to use neighbor command. So you need to go under OSPF. So router OSPF 1. So neighbor, who is your neighbor? 192.168.12. Enter. So go to R2 and use the neighbor command. Router OSPF 1. Who's my neighbor? 192.168.12.1. Just wait. This is from the adjacency. Show IP. I see non-broadcast attempt will come. Show run web section. Okay. It must form. Just clear once. It's not forming. Sometimes it creates a problem. Can you see? Loading is done. Show IP OSPF. We have DRBDR election again. Check the network type. What is the network type? Show IP OSPF interface 0. So what is the network type here? Non-broadcast. What is the hello and dead? 30 and 120. This part is clear. So now we'll change the network type to first remove the neighbor command. Neighbor is down because it needs manual neighbor command. One side neighbor command is also no. 168.1. Now we'll change the network type to point to point. So IP OSPF network point to point. Neighbor down. Why? Because of network type mismatch. Network point to point. Dynamic neighborship. To check the network type 0%. What is the network type? Point to point. Hello and dead 10 and 40. We check DRBDR election. There is no DRBDR election. Can you see here? There is no DRBDR. Clear? So, and we don't require any neighbor command. It's dynamic neighborship. Clear? Now, which is the network type to point to multi-point broadcast. Go to the interface. Interface name. IP OSPF network. Point to multi-point. Question mark. If you don't use the keyword non-broadcast, by default it will be broadcast. Enter. Point to multi-point. Neighbor down. IP OSPF network. Point to multi-point. Enter. We have a dynamic neighborship here and no DRBDR election. Check show IP OSPF neighbor. There is no DRBDR. Clear? Check show IP OSPF interface name. Can you see what is the network type? Point to multi-point. What is the hello and dead? 30 and 120. Yes. Any doubts? Morning. Okay. So show IP OSPF interface 0%. I shown that. It's point to multi-point 30 and 120 and dynamic neighborship and no DRBDR election. Correct? This is clear? No neighbor command. So now final network type is point to multi-point non-broadcast. So go to the interface. So IP OSPF, first remove that and then otherwise it will override. Show run 5 section. Go to the interface. And no. On domain lookup. You can disable this by using no IP domain lookup. What about clear, right? So interface 0%. No paste. No? So now we'll configure network type as point to multi-point non-broadcast. Enter. Interface name. IP OSPF network. Point to multi-point. Enter. Neighbor down. There is no neighborship. Why? Don't have any dynamic neighborship. You need to use a neighbor command. Wait for a few more seconds. Huh? Yes. Okay. So now we'll go to router OSPF 1 neighbor 9.168.12.2 router OSPF 1 and use the neighbor command 9.168.12.2. So in OSPF network type, point to multipoint non-broadcast, we don't have any DR-BDR election. Can you see? No DR-BDR election. Show IP OSPF interface. What are the timers? 30 and 120. Can you see here? It's 30 and 120. And this is a bug in UNG. Even if you enable network type as point to multipoint non-broadcast, it will show as point to multipoint. If you check show run pipe section OSPF. So what is the network type here? Non-broadcast. This is a bug in UNG. And you need a manual neighbor command now to make the neighborship. I hope this is about the network types. Anybody has any doubts? Clear? Okay. Now we'll move on to area types. So we have 5 area types in OSPF. We have normal area, or we call it as backbone. We have stub area. We have totally stub. We have NSSA. And we have totally NSSA. So now, first question is why they introduced these area types? Any idea why they introduced this? So why we require this area?
To minimize routing table entries.
Very good. To minimize the routing table entries within the area. Good. So any other benefit of using area type? Minimize
Flooding
flooding
can
of
be
LS
reduced.
is very good. To minimize the routing table size within the area. To minimize the flooding of LSA.
How it can reduce, like LSS should flood from areas to area.
Yeah. But if you to configure is a stub, no? So instead of type 3 and type 5 LSA, we'll be having just a simple default route for the reachability. We'll see in the lab.
Okay.
Filter the LSA. Filter the LSA. Yes, good. Filter the LSA as well. And even reducing the size of your LSDB as well. And your SPF calculations will be faster. So these are the advantages of using area types. So when you use area types, we have some limitations. So these must be present. So I'll talk about some limitations about area types. Done?
Just 1 minute.
Okay, sure. So let me know once done.
By default, there is no summarization, right? On the ABRs, we have to enable it, or is it by
No,
default?
it's not about summarization.
No. By default, ABR will send us a summarized route, or
No, not
we
the
have.
ABR. ABR will not summarize. I'll talk. Wait, just wait. Next, we'll discuss about stub. So I'll discuss very clear. Okay. So these are noted. Done. Done, Darshan?
Yeah, done.
Okay. Okay. So now we'll discuss about stub area. So why we need stub area? So let us consider we have R1 and we'll be implementing the same lab. So before this, just we'll talk about the limitations about area types. So if we talk about the limitations, first limitation is you can't configure backbone area, that is your area 0, with any area type. Means you can't make your area 0 as stub, totally stub, NSSAR, totally NSSAR. Second point, there must be an ABR. ABR present. Now to implement these area types. So every router inside a particular area should be configured with the particular area type. Done. Done. Done online guys. Done. Okay. Stop. So if you talk about stub, it will block your type file access. And no ASBR allowed. So now, so let us consider we have R1, we have R2. So we will be implementing the same lab. So we have R3 and we have R4. So this is in area 0. This is in area 1. So who will be the ABR? R2 will be the ABR. So let us consider we have 1.1.1/30. So we'll be implementing this lab and we'll see how this stuff works. Okay. So we'll be configuring this stuff, area stuff on the area one, because you can't make your backbone area as either stub, totally stub, and SSAR totally. So we'll be implementing our stub on the area one. So let's proceed to the lab. So we'll take 4 routers. So we have R1, we have R2, R3, and R4. So this is an area one. So area 0. This is area. /32. So we have a loop back on R1. The IP address between R1 and R2 will be 192.168.12.0/20. So between R2 and R3 will be 23.0. So between R2 and R4 it will be 24.0. So in order to prove this, I need a type 3 and a type 5 LSA, correct? So type 24. So now before that, let me on this. So R1, interface, this is repository. So IP address will be 92.168.12.1/. We have a loop back. IP address will be 1.1.1.1/. So in order to get a type 5 LSA, I'll be just using redistribute connected on the R1. So I need type 3 and type 5 LSS in order to implement this lab. So just go to router, OSPF 1, router ID, .1.1.1. So network, prioritize the network 192.168.12.0, wildcard mask and area 0. And I use redistribute connect. Yeah. So that I will see a type 5 LSA. So this is an R1. So R2. So interface Z0 bar 0 will be 192.168.12.2. We have interface Z0 bar 1. So the IP address will be 192.168.23.2/24. Motion. We have interface Z0 bar 2. And the IP address will be 192.168.24.2/20. Yeah, sure. We'll do that at the end of the class. So router OSPF 1. So router ID will be 2.2.2.2. So 12.0 is in area 0. So we don't want reach would connect here. So network 192.168.23.0 area 1 and network 192.168.24.0 wildcard mask and area 1. Done. So on R3, it's 0%. So IP address will be 192.168.23.3/. No share. So router OSPF 1. So router ID will be 3.3.3.3 and advertise the directly connected network. That is 192.168.23.0 area 1. Yeah, sure. So on R3 is done. So on R. So this is just the basic configuration I'll be doing on the notepad. So implementing stub and the area types I will be directly doing on the routers. So okay, on R4. So Z0 bar 0 will be 24.4. So router OSPF 1. So router ID will be 4.4.4.4. 24.0 area 1. So copy paste. Okay. So go to R2. No. No. So wait for the adjacency. So on R2, find 3 adjacencies. So IP OSPF name. Start. What happens in next step? Master and slave election. Okay. So come back. So on R3 and R4. So you should see one type 3 LSA, that is 192.168.12.0 OIA, and one route will be 1.1.1.1, that is OE2. Show IP route OSP. So we have a OIA route here, that is type 3, and we have type 5. Now, so when we implement stub on area 1, so what stub will do? Stub will block your type 5 LSA. and you can't redistribute the routes in the stub area. You can't redistribute means ASBR is not allowed. In simple words, you can't redistribute the routes in stub area. And a default route is automatically generated. Please make this, please make a note of this point. Default route will be automatically originated for reachability. So these are the points you need to remember about stub area. So in simple words, we can call ASBR is not allowed. When will ASBR come into picture? When you redistribute, right? Same routing protocol also you can. I use redistribute connector, right? So that I'm able to see that 1.1.1.1 is OE2. Can use redistribute connector. That's why when redistribution, I wrote that point as well. Can use redistribute connector. Clear? So now. Good. So okay. Now. So now we'll configure area 1 as a stub. So first see the ABR configuration. Very simple configuration. You need to go to router OSPF 1. The command is area ID 1 and stub on the ABR. Enter. Why adjacency is down? Area type must match. Now go to R3 and R4 and configure them as stub. So very simple command again. So router OSPF 1 area 1 stub. So go to R4 and configure it as. So now your type file is blocked. And it will create a default route for reachability. So check show IP OSPF neighbor. As this is up, check show IP route OSPF. Can you see there is no type file SA. Before that, we were seeing type file. We had a type file SA here, which router we checked. We checked on the R3 router. So if you check here, so before this, so we had a type file SA. We had a type file SA. Now after implementing the stub, it will block the type file SA. Show IP route OSPF. Can you see there is no type file SA, and it will automatically originate a default route. Can you see here? It's originated default route. Why? Just for reachability. Now we go to reach. Which is the default route, how will be able to reach, correct? I hope this part is clear. And one more point, no ASBR is allowed. So how to prove that? Let us create a loop back here. So, sorry. Loop back 0, IP address. So 3.3.3.3/32. Router OSPF 1. So redistribute connected. Enter. It will prompt you error. Just wait. Can you see? Without a valid area. So you can't redistribute the routes in the stub area. Clear? Means ASBR is not allowed. Even so, this is the part. Clear? Any doubts? This is about stub. Any doubts in the stub? Clear? Stub is clear now. So now, if you talk about totally stub. So what totally stub will do? Again, totally stub will block your type 3 and type 5 LSS. Again, ASBR is not allowed. So again, automatically originates a default route for a reachability. Let me quickly remove this stub configuration. So go to R2. Sure. Remove stub. Just go to R3 and R4 or remove stub. Sure. 5 section. Remove. Go to R4 and remove. Web section. Start. Now you should see both the type 3 and type 5. I have both type 3 and type 5 now. So what this totally stub will do, it will block both your type 5 and type 3 LSA, and it will automatically originate default route for reachability. Now how to configure that? So on the ABR, so you need to configure router OSPF. The command is area ID stub and no summary. So this is the command on the no summary means I don't want summary LSA. That is type 3, right? Enter. This is the configuration on the ABR, and on the other routers, you need to configure area ID stub. Simple. OSPF area ID stub. On all other routers inside the area, go to R4, configure this. Tell you the commands. 1 minute. Area 1 stub. So what I did, I went to ABR. I went to router OSPF 1. I configured area 1 stub. No summary. So on these two routers, I configured router OSPF 1 area ID stub. Done. Done on English?
So area 1 stub no summary is for totally stub, right?
Totally stub, yes.
Okay.
So on the ABR, you will implement that command. On all other routers, you will implement just the normal command, that is area stub. Done? Okay. So now go to R3 and R4. So go to R4 and check. Show IP route OSPF. So will block your type 3 and type files. Can you see there is no type 3 and type files? Just it has originated a default route for reachability. Done. So now we can't use sorry, we can't have a OSBR, ASBR here. So redistribute, connect. Enter. Again, it will not allow you to redistribute. It's not a valid area. You can't redistribute in stub and totally stub. Clear? If you remove this, then we'll move on to NSSA. So before moving to NSSA, just take a short break. We'll come back. So I'll remove this. Still 1 hour to go. So go to R3 router OSPF. So no stop. So go to R2. Just remove this. Sure. Pipe section. So stub is this. This is the type 3 and type 1. Then we'll take a short break. Show IP route OSPF. Nice. Okay, guys, take a short break. We'll come back at 9:12. Okay. So now we'll discuss about NSSA area. So NSSA stands for not so stubby area. So again, NSSA will block your type 5 license. So here ESBR is allowed. And so no. So automatic generation of default route. So you need to manually generate this default route using default information originator. So can anybody tell me why ASBR is allowed here? Because NSSA will generate type 7 LSA. Because we are not blocking type 7, we are blocking type 5. This type 7 is converted by type 5 by the ASBR. So that's why ASBR is allowed inside NSSA and totally NSSA area. So how to implement area 1 as the NSSA? So before that, sure, 5 section. So let me remove this. So now the configuration part. So you need to go to the ABR. Now you need to implement the router, OSPF 1, area, and the area ID and NSS. Enter. So go to R3 and R4, and you need to implement the same command. Go to R4. So now show IP route voice. Can you see? There is no type file LSA, but we don't have a reachable. You need to manually originate a default route. How? So you need to go to the ABR, that is your R2, and configure default information originate. Enter. This is how you originate a default route inside a particular area. You need to manually originate this. Your NSSA will not create a default route. Clear? Now go to R4. Can you see? O star N2. N2 stands for NSSA, type 7 LSA. So now we have reachability. Then you can redistribute as well. Go to router OSPF 1, redistribute, connect. Then if you go and check on R1, you will see a redistributed route. Show IP route. OSPF. Just wait. Should see a OE2. Loop back on R4. No loop back, right? Show IP. That was it. Just create a loop back. 4.4.4.4/30. Now I'll see a redistributed route. OE2. And redistributing NSSA. I hope this part is clear. So any doubts? Clear, right? Now
Can you repeat again that part? I missed it. I don't know.
ASBR. So here in NSSA area, ASBR is allowed. Means you can redistribute the routes inside the area 1.
So we externally that are E2 routes, right? OE2.
OE2 routes, yes.
Okay.
So in stub and total stub, you can't do that.
Yes, that is only for I understand that part, but can you again elaborate that NSSA and totally NSSA?
So what you need to know, tell me, in NSSA. So if we talk about NSSA, it will block your type file. That is blocked already.
Okay.
Correct. So and default route is not automatically originated. So we went to the ABR and configured default information originate. Clear? Then I went to R4 and use redistribute connected. Means in area 1 you can have a ASBR. This is the ASBR, right? Because you're using
Okay.
Yeah, this is allowed. Means in NSSA you can configure this. But whereas in stub and totally stub, you can't configure a particular router as an ASBR. Clear now?
Okay.
Clear?
Yeah, that is okay. So once you make that R2 as NSSA, what was the command?
Okay. So this was the command. So please make a note of this command. So router OSPF 1. OSPF 1. So area ID. NSSA, and I used default information originate. And on these routers, go to router, OSPF 1, area ID, and SSH. These were the commands implemented on the ABR and on other routers.
Just a minute.
Okay. Sure.
So once we without enabling it, we can see the routes as
OE2 and
in
OI,
the-
both the routes. Yes.
oh, can you show in the routing table of R1? Or just it's after the command implementation, right?
Yes.
Before, what was that?
Before we don't have any OE2 router. Can you see
No,
here? Where was
then
OE2?
how come the redistributed routes come in area 0 if we don't have
I
it?
use redistribute connected on R4.
No, that you use it after you make that area as an assisted default information originate, right?
No, you're totally confusing. See, default information originate, I use this command to create a default route just for reachability. This is for reachability. So without this command, your R4 will never be able to ping to 1.1.1.1. I think you missed
That
this completely.
means
Yes,
you mean there is no reachability without
yes. Default information originate. I think you missed that.
why it is so? Because we are doing redistribution and ABR we have connectivity with the backbone area and it should be, I think.
So see here. So okay, come back.
Yeah,
No,
just delete it.
No problem.
Delete it.
No.
Yeah.
So do show the pipe section. So just remove this.
Oh,
Okay, just wait.
area on okay.
Just I will configure area ID and SSH. Clear? On the API.
No, nothing, no configuration, nothing, no to configure anything. No, just normal areas. Okay. So
Okay.
now what is the routing table on R1?
R1. R1 will be the same. Just wait. Adjacency is down because of mismatch of area type. So let me quickly remove this.
Okay, yeah.
One.
Remove it.
Yes. This is up. Now you want to check the routing table of R1. So, show run. I is redistribute connected subnets. It should see a OE2 route. Can you see the OE2 route?
Yeah, it's OE2 routes are there, right?
Yes.
That are redistributed routes from the ASVR,
Yes.
right?
Yes.
Okay.
So now what you want to
Now, when you implement that as a NSSA, right?
okay.
What will happen?
So if you implement as a NSSA, this redistribute connected routes are allowed. Whereas in stub and totally stub, you can't redistribute. Means you can redistribute in NSSA and totally NSSA area. Clear? So okay, before this, let me quickly remove this. One minute. No problem. Just wait. So now check the routing table. I don't have OE2 here.
Yeah, it will not propagate because we don't have redistribution.
1 minute. Now I'll configure area 1 as this step. Just go to R2. Sorry, NSSA. Just go to R2. So router OSPF 1. So how to configure that? Area ID NSSA. Enter. So now go to R3 and R4. Configure the same. So that is area 1 NSSA. Done.
Okay.
Okay, go to R4. Configure the same. Sorry.
Okay. Now you make
one.
the area one as an SSA.
Yes.
right?
Now, check show IP route OSPF. Can you see? It has blocked type 5 LSA. Correct? See
Just
the
a
routing
minute.
table. Yes. Before this.
No, but
Tell me.
redistribution is there, or you remove that redistribution command?
So, see Darshan. What I want to prove here is in NSSA area, redistribution is allowed. Clear? Just that point I needed to prove. Because in stub and totally stub, you can't do redistribution. It is not allowed. Clear, Darshan?
No, totally stub and stub is a different concept. When that area don't have any exit point, then we can use that area as a stub and totally stub, right?
Correct. Correct.
And that NSSA comes into a picture if we have a redistribution.
Yes. No, NSSA will not come into the picture when you have a redistribution. I am telling NSSA, in NSSA, you can configure redistribution. It is not mandatory that if redistribution is there, then only NSSA area will come. No. I am saying in NSSA area, you can redistribute the routes. Clear?
What I'll do is I'll do the practical I have.
Yeah.
I'll ask you.
I think that will be the best thing. Okay, and then ask me that. Clear?
Yes.
Darshan?
Okay.
Okay. So we'll move on to total NSSA, or should I show this once again?
No problem. No problem.
No problem. Okay. So let's move on to total NSSA. So after the class, wait for 5 minutes. I'll just clear that out. Okay. So what total NSSA will do? Total NSSA will block your type 3 and type 5 LSA. So ASBR is allowed. And so automatically, it will automatically originate a default route for reachability. So let me go to R2 and review. Is done, noted. So please check before implementing totally NSSA. Show IP. And wire routes. So now if you implement area 1 as the totally NSSA, it will block your type 3 and type 5 NSSA. So area 1 NSSA and command is no summary. Break down the adjacency. So this is a command you need to implement on the ABR. On the other routers, just the normal command. Area ID necessary. Go to R4. Taper down. So wait for the adjacency. Show IP route OSPF. Now it will block your type 3 and type 5, and it will automatically originate a default for Reject it. And you can redistribute as well. Go to R1. Show IP route. Distribution. This is about parent. Yeah. Now. So now we'll discuss about summarization. So now tell me why we need summarization. This has been already discussed in EICR. Yes, guys, tell me. So why we need summarization? Yes, we need. Why summarization?
Minimize the routing table size
Okay. So minimize the routing table size.
and save CPU and memory uses.
Very good. Saves CPU and memory.
Avoid link flapping issue
Very
due
good.
to
So it will not avoid, but if link flaps, no, if link flaps happen, then it will not affect your neighboring routing table. So in OSPF, you can summarize the routes only on the ABR and ASPR. You can't summarize the routes inside the area. It is impossible. Only on the ABR and the ASPR. I hope everybody is good with submitting. And on the router, where you summarize, it will create a null zero route. Just to avoid loops. And what is the AD? So these many points you need to remember in OSPF about summarization. Done. So now we'll see how to do summarization. So we'll be taking two routers. So we have 172.16.0.0/24. So you need to answer this question. Then only I will show you summarization. 172.16.2.0/24. We have 172.16.3.0/24. We have 172.16.4.0/24. 172.16.5.0/24. We have 172.16.6.0/24, and we have 172.16.7.0/24. What is the summary address of these? How many? 8 prefixes.
172.16.0.0/22.
/22.
No, 21, sir. 3 bits. We need
1/21. Then which is correct? /22 or /20? Or we have /20 as well on the cards. /21. Manoj, okay. What about others? /21. Okay. Why /21?
we need 3 bits to represent 8.
Very good. Very good. So in order to summarize this, what is the summary? Summary will be 172.16.0.0/21. If it were 4 subnets, 0 to 3, then you will use /22. Block size. Clear? Now. So this will be in area 0. And this will be in area 1. So who will be the ABR? R1 will be the ABR. So you can only summarize on the ABR and the ASP. So we'll take 2 routers. Block size 8. Good, Manoj. So we have 172.16.0.0/24, 172.16.1.0, 172.16.2.0, 16.3.0, 16.4.0, 5.0, 6.0, 16.7.0 slash. These are the loopbacks on R1, and these will be inside area 0. This will be in area 1. Area 1. So the IP address will be 192.168.12.0 slash. Who is the ABR? R1 is the ABR. It's okay. Post it. We'll just use a notepad. So on R1, Z0 bar 0 will be 12.1. So we have interface loopback 0. Operators will be 172.16.0.1 slash 24. Four, five, 8. Loopback 1. Loopback 2. Loopback 3. C.1. Loopback 4. 4.1. Loopback 5.1. Loopback 6. 6.1. Loopback 7. 7.1. So these are the okay, sir. These are the 8 loopbacks. We'll be configuring one. No? So enable OSP. So router OSPF 1. Network 172. 16.0.0. 0.0.255.255. Area 0. And network 192.168.12.0. Wildcard mask and area 1. Enter. Go to R2. Interface Z0 bar 0. IP address would be 192.168.12.2/20. Router OSPF 1. So network 192.168.12.0. Wildcard mask. Wildcard mask. Clear? Sharp. Clear? Okay. Now, wait for the adjacency. Show IP, OSPF, name. Start state, master and slave. What happens in exchange state? Exchange. DR in exchange. Two ways DR BDR. What about exchange? What? We won the election. One exchange. Very good. With the help of which packet? Hello packet will exchange the DVD packet, database description. Okay. Show IP OSPF neighbor. So we have a neighborship. Go and check the routing table of R2. Show IP route OSPF. All the OR routes type 3. Now you need to go to the ABR and perform summarization. Now how to do that? You need to go to router OSPF 1. The command is area ID. So what will be the area ID? Should I use area 1 or area 0? Why? So area 0 is correct, but why?
Because our loopback
Because
routes
your
are in
loopbacks are falling under area 0, right? Simple. That's all. This is not like this. You should need. Okay, area ID range. This is the command. And then summary IP and the summary mask. That is 172.16.0.0, 255, 255.248.0. It's not 252. 252 is for block size of 4. For block size of 8, it is 248. That is /21. Enter. As soon as you summarize, check show IP route OSP. Can you see it has created a null zero route? So go to R2, you will see a summary. Wow, /20. This is how you summarize on a API. That is area border route.
So overall is when we are doing summarization, right? So we have a null route in our routing table.
Yes.
Same goes in EIGR.
Same.
Goes
Yes. BGP as well. Even BGP will, when you aggregate the routes, no, same thing. It will create a null zero. Clear, guys? Now, so now you need to tell me. So just quickly remove this. Push over pipe section. No, I hope this is clear, right? Summarization. Now I want to see these routes as the OE2 routes. How to do that? OE2, external routes.
redistribute connected.
Yes, redistribute connected. But so you can just remove this command. Don't want to advertise these loopbacks, no. Instead of this, use redistribute connect. Enter. So we'll see these routes as OE2 routes. OE2. All the routes are OE2. Now, who is the ASBR? R2. How R2 will become the ASBR? What do you mean by ASBR? Yes. Why R2 is the ASBR? Answer is almost
Interfaces
correct.
on different, yeah, if we have
Tell me.
interfaces on different routing protocols, we call it as ASBR.
Okay,
That
okay.
router.
Interfaces in different routing protocol.
Routing protocols.
Okay. So yes, we know. Why R2 is the ASBR? You are near, very near. How?
It's on different area.
Different areas ABR. Area border route. Where you use redistribute.
I think R1 is ASBR. Why we are seeing?
No. Here, one of your friend answered that I'm asking. One of your friend answered R2 as the ASBR. So I'm asking him how. So he will never become the ASBR. Don't worry. Just for this. Clear, I think it is clear, no? Okay. Now we'll see how to summarize on the ASBR. So your R1 is the ASBR where we use redistribute command. So how to summarize here? This is the command summary -address. And you need to mention the summary IP and the summary mask. That is 172.16.0.0/21. Enter. This is the command on the ASBR. So if you go and check on R2, you'll have a single summary address. And it will create a null zero route. Show IP route, OSPF. Null zero. Clear? So I'm done for today. So tomorrow we'll not be having any class. So this Saturday, I'm a little bit busy, it's a little bit emergency. I need to go to some place tomorrow. So we'll have a class on next Saturday. Okay. So from Monday, it is as usual. Okay. So still 2 more topics are left in OSPF. We have filtering. And we have one more topic, that is authentication. So it supports 4 types of authentication. So we'll talk about these 2 and then we'll move on to BGP. So by next week, we'll be finishing with this course. So anybody has any doubts, guys? Yes.
Chetan,
Yes, Darshan.
my CCNA got expired. Can I give direct?
You can write CCNP encore, right? What to say? Nowadays, nobody writes CCNA because what is the problem with CCNA is you can't write the exam for CCI lab. So if you write encore, no, CCNP encore. So
Okay.
you can write CCI lab exam as well. Now don't write CCNA. Leave that CCNA now. That is done.
No, CCNA I left, but CCNP in core.
And core you write. Yes. That will be helpful
So-
for your CCL lab as well.
Yeah. Do
Yes.
you have the dumps? Do you have the
Dumps, no,
dumps?
you need to contact Sushil sir.
Okay.
I'll just
okay,
text you in the WhatsApp. So you can just contact him for the dumps.
Okay. Okay.
Darshan?
I'll do it.
So any
Yeah,
other
thank
doubts?
you. No, thank you.
Okay, guys. Others can leave except Darshan. Darshan, please wait for 5 more minutes. Let us clear the topic. Done. Clear, right, everybody? So you people can leave. So others can leave, guys. Thanks. Thanks so much, guys. Have a nice weekend. We'll meet on Monday. Yes,
Chetan,
Madam. Yes.
so actually this, what we are, the course we are doing now, what you're teaching now is Encore only, right? Part of,
Encore, yes. Encore
Okay.
and NRC.
or even
You can take this
NS.
one, yes. So
Okay.
all the topics we are covered. Yes.
Okay, thank you.
Okay.
But Chetan, I also had one question. Probably
Yes.
I'll ask after Darshan.
Darshan, okay, sure, no problem. Yes, Darshan, what was the doubt? What was the problem with that? Oh, let me stop this recording.